Okay, so suppose you want to test the probability of flipping a coin. And of course, with a coin, when you flip it, right, there are two options, heads and tails. So essentially what this means is, since there are two options, and one of them is heads and one of them is tails, that means the probability of flipping a heads is 1 out of 2, right, or 50%, or whatever you're looking at. And the probability of flipping a tails is also 1 out of 2, which is also 50%. Now, when you actually test this is theoretical right here. Anything could happen, right? On a small scale, anything could happen. So experiments here. Let's say you're running a trial, and you experimental probability looking at the coin, and you're flipping it 50 times. So you have 50 flips. What should happen? Well, the closest estimation of what should happen is that you'll have 25 heads, right, and 25 tails. And of course, if I'm trying to express this as a ratio, right, what we might do is say that, okay, 50 flips, 25 heads, 25 tails, that means out of the total, there's 25 out of 50 heads and 25 out of 50 tails. But if we want a part-to-part ratio, right, of heads to tails, what we can then say is that there'll be 25 heads, right, for 25 tails. Let me write this over here. 25 heads for every 25 tails. And that, if we reduce that, we get a 1-to-1 ratio, right? There should be as many heads as tails. That's what 1-to-1 ratio means. Now, if we were to describe an experiment involving this coin, and let's say 3 people, that would let you test this out to see if the 1-to-1 ratio makes sense, what could you do? Well, I mean, you would want to flip as many times as possible, right? And you know, let's say, it depends how they phrase the question, of course, but let's say the experiment will involve tossing a fair coin 50 times, and you're limited to that. If that's the case, and you have 3 people flipping the coin, I think it makes the most sense, right? You have 3 people passing this coin back and forth. And again, I'm only constraining myself to 50 flips because that's usually what I see or have seen on many test examples where they say, okay, you've got 50 throws here, right? That's your experiment. And you've got 3 people to run the experiment. What do you do? That's why I'm answering it this way. Of course, the logic here is you want to flip as many times as possible. So I don't know why we would constrain ourselves to 50 flips. But anyway, so we have 3 people. What I would do is have each person flip the coin, right, about the same number of times. Of course, you can't do that with 50, so you have to assign an amount of flips to each person. Maybe the first person flips 10, then the second person flips 20, and the third person flips 20 times. Your goal is to keep it as random as possible. And maybe in the experiment, you could also say something like a person has to flip the coin, right, a certain height, like an estimated height. In other words, you have to actually flick it off of your hand, let it spin in the air, land on the table, right, so that you're not controlling the way the coin is flipping. It doesn't matter what the height of the coin is in your flip, just as long as you have some procedure that almost guarantees it's a random experiment. Because otherwise you'll have just a person placing the coin down, right? They just place it down on the ground. They can easily control what side it lands on. So you want to establish in your experiment that you are keeping it random, that you're flipping the coin enough to not be able to control how it lands. And that's, I would say, something along those lines. All right, thanks.